Okay, for the Google Sheets instructions this week, I actually went out and bought a ton of scratch tickets. It took me probably way longer to make this data set than it'll take for you to analyze it, but if you get stuck, if you're not sure what I'm asking for, as always, let me know, okay? So I went out and bought a bunch of scratch tickets. You could look at the photos of each of the sets of scratch tickets just to prove to you I'm not lying. And then if you click, just like usual, click your Google Sheets data set. Yours will look a little different because I'm the owner of this. You'll want to do just like what you do normally each week. Okay, you want to take the data set, copy it into your own Google Sheets slide. So I'm going to hit Edit, Copy, and then I'm going to go to Google and search Google Sheets. There's Google Sheets. Click Go to Google Sheets. Make a new one and sign into Google. That way it saves your work while you're working on it. Then you can click the top left cell and then you can hit Edit, Paste. And there's all your numbers for you to work with. Okay. I wish there was a button where you could just copy into it directly into new Google Sheets. There might be, maybe I just don't know how to do it, but on your slide, I checked on your end, it doesn't look like you can directly copy it. So that's how you get your numbers. So the goal is to just, like expected value is something we calculate in Newton this week, and we use previously determined probabilities to calculate expected value. What expected value means in this context? Expected value is how much would you expect to win or lose playing this game per scratch ticket. Okay, and it's going to be negative. I think with all these it's going to be negative because you should expect to lose money if you play the scratch tickets again and again. Like for instance, if you ran the numbers on like a blackjack table, you were watching the dealer, watching like a player from the public come to the blackjack table, and you kept watching the game, calculating how much money went to the dealer, how much money went to the person. You could find out how much money you would lose on average per game. Maybe it's like just 92 cents per hand. Okay, but that's what expected value is how much do you lose or how much do you gain on average for one item. So to start that process, calculate how much did I lose on the $1 scratch tickets. And in order to do that, what you want to do is, well, this is the $1 scratch tickets. It's out of order because of the way we scratched them off. Me and my buddy sat there and scratched them off. We lost a total of, you can type equals sum if you want to be lazy and not think about the other way of doing this math here. Whoops. Just because I'm zoomed in. Equals sum, parentheses. I'm going to start on D2, and I'm going to put a colon, and then put D11. So I spent $10 on the $1 tickets because I bought 10 of them, and I won $3. Total lost here was $7. I lost $7 for the $1 scratch tickets. Okay, so I think that's all part one is asking for you to do, is to go through. Yeah, part one asks you to go through each of these, the $1 scratch ticket, $2 scratch ticket, find out how much I lost. Take into account the winnings that I got. Like this ticket, I won $2. This ticket, I won my $1 back. I broke even on that ticket. So calculate how much I lost for each of the tickets. Okay, I didn't buy 10 of the $10 tickets because I realized as I started calculating this in my head at the gas station, I was like, I'm spending a lot of money here. You can even calculate how much I earned. It's not a lot back. It was a huge loss for me. Part two, what's the expected loss per ticket? In other words, how much money would you expect to lose on one ticket based on these numbers? So I can do this for you for the $1 tickets. Now I lost $7 on 10 tickets. So the expected loss per ticket is going to be the $7 I lost divided by the 10 tickets that I had. That way you break up the loss evenly amongst those 10 tickets. And that's what you've been doing in Newton with expected value. 7 divided by 10 gives us. So I expect to lose about 70 cents per per winnings. So the expected value, we'd say, it's slightly different. Expected value means you use a negative sign if it's a loss. You use you just leave it positive if you're gaining something for each ticket. So expect to lose 70 cents for each of the dollar tickets. So that's what you got to calculate for these. Then part 3 says you bought 365 of the $1 tickets. How much would you expect to lose? So use your answer from part 2 to make this calculation. Okay? So think about what expected value means. It means how much we expect to lose for just one item. If you buy 365 of these items and you lose 70 cents each time, how much money should you expect to lose in total? Then part 4, if you shuffle these tickets in a hat, you draw one out randomly, what's the probability of that it's a losing ticket? What you want to do is maybe count up the number of tickets that there are total. There's 10, 20, 30. You know, you count up how many tickets I bought. That would be the total amount of tickets. And then you want to count up the, I think it asks for probability of a losing ticket. So count up the number of tickets that are losing. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 losing tickets here. Right? Go through all the columns and do that. Count up all the losing tickets, because the probability is the amount you're interested in divided by the total. So count up the number of tickets you lost that were losing tickets and divide by the total number of tickets to find out the probability of a losing ticket. Okay, the point of this, this ties in with what we're doing with Newton, but another big point is that I just hope everyone does scratch tickets with clear eyes, right? I just did it. I put a lot of money into it all at once so we could see what happens. There's a lot of losing tickets, okay? And if you flip over the scratch ticket, even in small print, it's honest with you, and it says, hey, like 2.5 out of every 3 tickets is a losing ticket. It means like 5 out of 6 tickets are losing tickets, or something like that. It'll tell you the odds in the back. The odds are not good. You might think there are strategies where, you know, maybe you want to pick a certain number out of the deck. I assure you that the people running this company randomize things to make sure that there's no sort of pattern, because, you know, that's easily schemable. Like you can take some money from them. And actually, my math teacher when I was in college had a son who went to MIT, and he found a scratch ticket scheme that he actually figured out how to exploit it. And it wasn't by just like picking a certain number. The only way you could exploit it was you can actually look it up online. Here, maybe we can find it together. Scratch ticket MIT. Yeah, right here, how a group of MIT students gamed the Massachusetts state law. So they figured out like there's a scratch ticket where if nobody won like the grand prize, the amount of money spilled over into the second prize, I think, and then from second prize spilled over to the third prize. There's articles written about it, but they had to get like investors in order to make this happen. They had to like have $400,000 or something. So if there's a way to beat the lottery, somebody smarter than me has thought of it. Okay, somebody smarter. I don't. You guys are smarter than me, certainly in other ways too. But I think about it. I can't figure out how to do probability. I'm the nerd that chose to be a math major. If you can think about it, run it by me or run it by a mathematician, and let's figure it out together. If you think you have a way of scheming the lottery system, I'd be happy to talk with you about it, because yeah, that'd be cool to make some money. But the point of this was to get a data set and show that it's really unlikely that you win. Look, I had a $5 one that won me $30, but then I also had many $5 ones that won me nothing.